All right, test number 1. So they're gonna the format of these they're gonna do with you guys is they're gonna give you A and B. So you sketch it, you write all your variables here. So this is your practice problem where they say, hey, write your variable here. Pretty soon, like we do with all units, you're gonna start with writing your variables on the side. Okay, so let's look at this. A boy kicked a can horizontally from a 6.55 meter high rock with a speed of 4.0 meters per second. So, start with the sketch. Don't overkill this. It's a sketch. It's simple. Here's a kid. He's standing on a rock, right? Here's our rock. He kicks a can. Bam. If you want to write the speed, you can say, hey, kicks it at 4.0 meters per second. It's just meters per second because that's a speed, not an acceleration, right? And the cliff is 6.5 meters. I like to highlight stuff or underline it, whatever, because that's the smart thing to do. Now, we're going to fill in all these variables. Now it's like, yo, they give us 2. How are we going to fill in 7? Well, there's going to be a handful that we don't know, and there's going to be some that we're going to figure out. And there's going to be some that don't exist. So let's look at this. The x displacement. So obviously they don't tell us this. So this is the can kind of going. But the x displacement is, yo, how far the can goes. So does that exist? If I kick a can off a rock and it falls down, there's going to be an x displacement. So that does exist. So in this case, we're going to put a question mark, meaning it exists, but I don't have it. The y displacement, how high is it up? Do we have that? Yes, 6.5 meter high rock. So that is going to be 6.5 meters. Next, the x initial velocity. We do have the x initial velocity because that's the speed at which it was kicked, right? So that's 4 meters per second. In the problem, I'm just going to say 4, but this I'll say 4.0, same thing. Okay, the y velocity. Okay, there is no y velocity. This is always going to be 0 unless they specifically give you something. Like he kicks it downward, something like that, you know. But for this case, he kicks it sideways. So the y velocity is going to be 0. In other words, it doesn't exist, it's 0. Okay, the x acceleration. It doesn't accelerate because he kicks it straight up at 4.0 meters per second. So this x acceleration will be 0. So this doesn't exist. Okay, these two by default will be 0 unless they tell you. Okay, good. Y acceleration. Well, this is an easy one, hopefully. This is the acceleration of gravity. Anything that gets dropped will accelerate towards Earth at the acceleration of gravity, which is 9.8 meters per second squared. So this is the units, but 9.8 is the number. Okay, time. How long does it take to hit the ground from when it's kicked? Obviously, time exists in our dimension, so we have it, but we don't. It exists, but we don't have it. So that's going to be a question mark. So we don't have these two. We have the rest, and these two are 0. Now, let us solve for time. That's C, right? So time, usually you're going to have to pick, let's write down our formula first. Displacement equals initial velocity times time plus 1/2 acceleration times time squared. Now, we're solving for time. So let's pick the displacement that we have. In this case, it's the y displacement. So again, I'm going to rewrite my formula. Y displacement equals initial velocity, y velocity, by the way, times time, which we are solving, we don't have, plus 1/2 times the acceleration of y times time squared. So we're dealing with y. What's the displacement of y? Well, they give it to us. 6.5 equals. What's our initial y velocity? Well, let's look up here. It's 0, right? So for this one, I'm going to plug it in. 0 times time, which we're finding, plus 1/2. What's the acceleration of y? Well, let's come back up here. 9.8 times time, we're finding, squared. Okay, let's rewrite. Let's clean it up. 6.5 equals 1/2 times 4.9 times time squared. I encourage you to extend your steps. If you know something automatically, hey, do a step for it anyways, because this is your thought process you're writing down. So if you get confused in 2 pages and you're not in the class, you can't ask questions, you can go back and look at your thought process. Very important. Or if you screw up, I can see, oh, okay, I see here, because I see your thought process, and this was supposed to be a 5 or whatever, you know? All right, so let's do step 4. 6.5 equals, oops, see, I screwed up right here. I should have put 9.8. I already did it. So this is 9.8. Now we're going to multiply it 4.9 times time squared. See, that's good. I'm glad I wrote that. Now, I divide this out. 4.9 divided by 4.9. So we have, we'll say 1.326. So up here, 5. I'm going to flip the time to the other side. So this is gone, right? So we have t squared equals 1.326. Goes on, but that's where I'm stopping. Now, I want just time. I don't want time squared. It doesn't say solve for time squared, right? Solve for time. So what I have to do is I have to square root this side, which means I have to square root this side. So now my step 6, time equals about 1.15 seconds. So there, I'm going to box my answer so it's easy to find. That's my time. So now that I have time, now I can solve for the displacement that I do not have, which is the displacement of x. Okay? So, let's write the formula again. Displacement of x equals initial velocity, which we're dealing with x, times time, plus 1/2 acceleration of x times time squared. Now I plug in what I know. Displacement of x equals, what's our initial velocity? 4 meters per second. 4. What's our time? Well, now we know our time. 1.15 plus 1/2. What's the acceleration of x? 0, right? 0 times 1.15 squared. So, this whole side's gone, right? Awesome. Displacement of x equals 4 times 1.15, and that's it. So the displacement of x, calculate that sucker up, you should have gotten 4.6 meters. So, did we have to write a little bit more than maybe we wanted to? Sure. Did we have to solve one thing so we could solve the next thing? Yeah. But it wasn't really that bad, right? I mean, you're just multiplying and dividing. It's just now you don't just mindlessly multiply and divide. You just got to know where to put things. That's the difference between algebra and physics. Is physics, you both divide and multiply. But physics, you have to put things in their certain spots, right? That's it. Put it in the spot, and then you either multiply or divide. And then sometimes you square root. Easy. So, same formula. We just do different parts of the formula. Go back to this one if you guys got questions. Further on in this unit, like when you get to the last few pages, they're not going to give you this, they're not going to baby you with hey, draw the picture, hey, this is the variable, we started it, just write it in. Like when you get to here, this is number 7, by the way, you just do that stuff yourself, and I promise you, if you do that stuff before you start the problem, it is going to be a piece of cake. They might not even tell you, hey, this is a 2-part problem. They might just say, hey, find this. And then you realize, oh man, well, I can't just immediately find it, I got to find this other thing first. And it'll be a piece of cake. Alright guys, you're going to do great.